What happens if you don't scavenge, take care of, convert these reactive products? They can do a number of very damaging things to biological systems. They can oxidize proteins, and the example I've shown here is an antioxidant enzyme itself called PON1, protects against atherosclerosis. Very important enzyme. It's inactivated by oxidative stress. And so if you have high levels of oxidative stress, the levels of PON1 circulating in your plasma go down. They go down in many, many diseases, in rheumatoid arthritis, in multiple sclerosis, in diabetics, in patients with autoimmune diseases. It's a marker of what's going wrong in this system within your body. Too many oxidants are being produced. They're damaging proteins and enzymes. They can also damage fat, lipid molecules. And when that happens, it produces something you've probably heard about, TBARS. TBARS is an acronym, but it measures oxidized polyunsaturated fatty acids. Polyunsaturated fatty acids are not bad. They're essential for life. Every food you eat has some polyunsaturated fatty acids. You use it to synthesize your own cell membranes. But this free radical can damage that biological family of molecules as well. So it can damage proteins, it can damage lipids. It can also damage DNA. Another category of biological molecules, and everybody knows DNA is important. That's what constitutes your genes. It's what makes each of us different. It's what gives your children characteristics that they inherited from you. Sometimes good, sometimes bad, but that's the way that goes. The same free radical can damage DNA. Again, not a good thing. So here's a third category of biological molecules that can be damaged by DNA. Damaged DNA is called mutated DNA. And the right mutations in the right genes can lead to cancer, one of the biggest health problems we face. Again, the result of free radical attack on our DNA. And the free radicals can also signal events in our bodies. Some of these are not always damaging, and in the right place at the right time, they're good. Fibrosis is formation of scar tissue. So if you cut yourself, you want that wound to heal as quickly as possible. And fibrosis helps that to come about. However, if your heart becomes fibrotic, it's medically known as heart failure. The pump quits working at its normal output. Not good. Apoptosis is actually programmed cell death. It's a way by which cells can die. At times, that's good. When you're an embryo, this process of apoptosis actually is what carves out your fingers from what looks originally like mittens. And as the fetus develops, everything goes normally, and you develop hands and fingers as you should. So apoptosis is not a bad thing in the right place. But if the cells in your heart undergo apoptosis, it's not a good thing. The cells in your brain undergo apoptosis, and you may be diagnosed with Alzheimer's disease. So all of these things require balance. Some of them are universally bad. Some are bad only when the amount is incorrect. This slide was the result of work that took place throughout that previous graph that I showed you in the last 40 years. And so this was pretty much in place well before Protandim came along. We knew all of this happened. We knew what free radicals do that damages our bodies.